to end up in this class. They put me into a different group. This is my class over there. I think over there, I think over there. I don't know. So I'll just walk over the steps. Okay, we're gonna walk into the building. We're gonna walk into the building.
Please speed up the process.
Oh, what's this? What's this?
Guys, if you want to put your stuff here, it's just as good as that. Okay. Okay, all in sit on the floor.
Lunch area?
Yeah, why don't you go in too?
Is this for their lunches?
Backpacks, lunches, coats. They don't need them right now.
Oh, not yet.
Right now.
They're over there.
Go ahead and take your things off.
Way to go over here. The heck is this?
Okay, shirts and bars, stop room. Yes, I say it's in
Alright, you guys can fill in, just start making like a line. Like I said, shoes across the face. Well, alright, or knees up, like you guys do knees up so that everybody can fit in here. Come on, Jenna, lift your knees up. Hey, there's a lot more before we get lift your knees up. Before you get sick. Please sit with your knees up so that way other students can come in and sit down too.
Okay.
Guys, just start filling in, sitting right in front. Abraham and Edwin, please fill your knees up so that people can sit. Now let's fill your knees up so that people can sit. Looks like John.
Go ahead and find a spot.
Just fill in right in front.
So you're going to look up your way. So you are safe. You can't have one other class.
Lulu, scooch back to your right in front of Baku.
Staff, we need room for Obi.
So Baku's in the back. Well, sort of. We're just sitting right now. We're all going to be sitting in our groups in a minute. Alright, find a spot wherever we're going to see them in a little bit. So just everything. Try and scooch back, legs up, so that way people can sit in front of us. So legs up, crisscross, or knees up. And we got to sit on the floor. Scooch back as far as you can. Here's a little more. Another group coming in. So scooch back. Good morning, everybody. Come in, have a seat. Scooch back, gentlemen and ladies. Scooch backward.
I am going to let you know, those of you in the back row, careful standing up. That shelf is really hard. Okay? So just be careful standing up. All right. Can I have everybody's attention, please?
Yes, you may.
Thank you, everybody. Welcome to Fermilab. This is the first part of your tour is going to be over here in Letterman Science Center. You will be working with a partner. Each pair of you is going to get a clipboard with a pencil and a cover sheet. Then we're going to divide you according to docents because there's such a, we're the docents. So we're going to divide you up into 4 groups, 1 group for each docent, and the docents will lead you around. The building is divided into 4 rooms of hands-on activities. Each activity is going to have like a little illustration on the wall, and each activity is also going to have a sheet that you can fill out. You're not going to get them all done. We want you to enjoy yourself and learn a little bit. And then we'll eat lunch outside. It's really nice. And we'll head over to Wilson Hall, and then a little later on at the end of the day, we've got time scheduled with a scientist. Quiet. Listen up. Does anybody have any questions? Did I cover everything well enough? Okay.
Oh, sure.
Oh, sure. Yeah, she wasn't even listening. All right, so what we'd like to do, are the students divided into 4 groups?
Yes.
Okay, how are they numbered, lettered?
Well,
How are they
you didn't have, so by classes. So if you were on the bus with me, so if you were in Baku and you're on the bus you're going to be in my group. And then if you were on the bus with Miss Flatley, so you'll be going with Ms. Lopez, and then Miss Katz and Miss Flatley, you guys will be going with them too. All right, so can I have a chaperone over here that the students will know to follow? There we are. All right, well, since you're right next to Miss Flatley, do you want to take this? Yes. My favorite is right. What do you guys say? Listen up, everybody. And as you walk over here, partner up. Kind of buddy, and quickly take a shot.
I know this is a large group, but I need to have, if you can move up just a little bit. Thank you. Thank you. Come on, guys, move up a little. Now I don't have to shout and that. All right. I'm Nancy Lanning. I'm one of the docents. And we're splitting you up into areas so you can talk to your fellow classmates about some of the other areas. But right now, the area that you're in is accelerators. So, what did you learn about, how much do you know about Fermilab?
Nothing.
Nothing, okay. All right. So, that's okay. That's all right. A lot of people who come to this laboratory, can I ask you not to videotape? Thank you.
Every couple of months, but I do like just going to my and my G work. So I
Oh my God. We're all the way over here. A Pikachu card.
all kinds of other stuff. The list goes on, right? But for him, I didn't go to the usual because his providers are, except our family doctor.
Hey, let
Oh God. We're all the way up here. The brothers. They're there. They're walking. They're walking. Okay, goodbye.
Guys.
Welcome to Fermilab, America's particle physics and accelerator laboratory.
Okay.
Our 6,800-acre site is home to some of the most cutting-edge science you will find anywhere in the
Does it
world.
look like a cure?
Google Maps.
Fermilab is one of 17 national laboratories owned by the U.S. Department of Energy. The laboratory's 1,700 employees, many of whom work in Wilson Hall, represent a diverse spectrum of people hailing from countries all over the world, working on a variety of jobs. And with thousands of scientists from around the globe using accelerators, detectors, and computers for their research, Fermilab is a national laboratory with a true reputation. Fermilab's mission is to uncover the mysteries of matter, energy, space, and time.
Okay.
Scientists at Fermilab are seeking to understand the smallest and most fundamental building blocks of our universe to find out why it works the way it does. We use enormous particle accelerators to send subatomic particles hurtling into targets at nearly the speed of light, and we build gigantic particle detectors to study the properties of those particles. We also help build particle accelerators and detectors for experiments in other parts of the globe. At 2 miles around, Fermilab's main injector is one of the largest and most powerful particle accelerators in the world.
Wow.
It sits 30 feet below ground and uses hundreds of magnets to steer intense beams of subatomic particles. Those beams are then used in our various experiments, studying fundamental particles like neutrinos and muons. Fermilab is at the forefront of neutrino physics research, studying these tiny, elusive particles with remarkable precision. In a cavern 350 feet below ground, we operate 3 massive neutrino detectors for the NOVA, MINOS, and MINERVA experiments. Our accelerator operators can send a beam of neutrinos through these detectors and then through the Earth to Minnesota, where even larger detectors await to measure their interactions with matter. The upcoming neutrino experiment, which will see a second beam sent to a detector in South Dakota, will be the best of its kind in the world. Fermilab's muon experiments could open the door to new discoveries. Located to the south of Wilson Hall, the muon campus will host experiments that will search for undiscovered particles and processes in nature. We also have an enormous stake in the Large Hadron Collider, the world's most powerful particle accelerator, located at CERN in Switzerland. Fermilab is the second largest contributor to the CMS experiment, one of the 2 that discovered the Higgs boson in 2012, and we are the U.S. hub for more than 600 scientists working on the LHC. We built components here for the LHC accelerator and CMS detector. In our remote operations center on the first floor of Wilson Hall, Fermilab scientists monitor real-time data as billions of particles collide at near light speed in the LHC. More than 95% of the matter and energy in the universe remains a mystery. Scientists at Fermilab are building cutting-edge tools to solve the puzzles of this dark matter and dark energy. In addition to improving our understanding of the universe, our innovations have gone on to improve the world. Particle accelerators are used in hospitals around the world for diagnosis and treatment. They shrink tumors, make better tires, clean up dirty drinking water, and do so much more. At the Illinois Accelerator Research Center, we work with our partners from universities and industry to develop new applications from our advances in science and technology. For decades, Fermilab has enjoyed a great relationship with the surrounding communities. Our education department works with roughly 20,000 students and more than 300 teachers each year, and our Letterman Science Center offers hands-on educational fun for kids. Our arts and lecture series brings top-notch musical acts and world-class speakers to our Ramsey Auditorium. And our 1,000-plus acres of restored tall grass prairie, along with our fishing ponds and bike trails, are welcome attractions for nature enthusiasts. We even have a herd of bison, better known as American buffalo. For more information about our research and programs, please visit our website at fnal.gov. Thank you, and we hope you'll visit us here at
What?
Okay, the scientist is right.
I have liquid nitrogen here. Why do we use liquid nitrogen here in our lab? To make things go slower, to make them get colder, to make particles go slower and slower, so that something I didn't talk about yet, I don't know if the other groups did, we have superconducting magnets here. Superconducting magnets have to get really, really cold to work efficiently. Minus 450 degrees, as a matter of fact. So we use liquid nitrogen and liquid helium to cool them. Now I want everybody to listen.
I like how you do that. Can I use it? Oh.
What do you hear?
I know what happened.
Does that remind you of anything that you sometimes hear at home?
Refrigerated?
Boiling water. Yes, it's boiling in here because this dewar is room temperature, and at room temperature, liquid nitrogen boils. In fact, it boils at minus 321 degrees Fahrenheit. I'm going to show you a few things that we need to know about with regard to liquid nitrogen. Liquid nitrogen has a pretty high expansion rate. What's expansion? Get bigger. And what do I mean by expansion rate? Does anybody know? Can I ask one of you to get out? Expansion rate. Yeah. Okay. I'm sorry, what? How fast something gets bigger. So we have to know the expansion rate of liquid nitrogen because we put it inside closed containers. And when that heats up, it gets bigger. Thank you. When that heats up, it gets a lot bigger. So we have to know what that rate is. And it's my recollection rate, it's about 700 to 1. Yep. All right, so, I filled it too full. All right, so I'm going to demonstrate that expansion rate. I poured a little liquid nitrogen in here. It's like a giant metal test tube. Let's see what happens. So what's happening inside here?
Pressure's building up.
It's building up pressure, I hope. I might have poured out too much now. While we're watching that, we're going to do another experiment. Everybody keep their eye on this. This is, shoot, it's been so long since I've done this. A bimetal strip. In other words,
is it sharp?
What color is this? Kind of a brownish. What color is this? Like a silver color. It's two different kinds of metal, brass and nickel. Something like that. Stainless steel, brass and stainless steel. What's going to happen when I put this bimetal strip in a container of liquid nitrogen? Any ideas?
It's gonna melt.
You think it'll melt? Any other ideas? I'm sorry? Change colors. And somebody over here said something? Okay, anything else? Freeze. Dark pattern. Let's take a look. Watch the handle. What's happening? The handle is moving. Why would that be happening? Keep in mind there are two metals in this bimetal strip. What happens when things get cold? What happens inside them to the molecules, the particles? They stop moving and shrink.
Hit the folk. Dabble.
They align and they get closer together. Which side do you think the atoms got closer together than the other side on? Did they get closer together over here more than over here? Or more on side A than B or more on side B than A? Wait, is it going to straighten out again? It's starting to straighten out, yeah. Why is it starting to straighten out? All right, so which side did they get closer together on? Boy, I really messed up this experiment here. Uh-oh. We're going to do this, and it's going to work. I didn't feel a thing, as a matter of fact. Why did nothing happen? That's a really good question. You know, I could pour it on the table, and all it would do on the table is kind of roll around. Do it Alright, so let's get back to that question. Why did I not feel anything when the liquid nitrogen landed on my shoe? If I could pour it on the table and nothing would happen when it bounces around, why is that? Why is it when I pour liquid nitrogen on the table, and I'm not going to do that right now, but why is it that I would pour it on the table and it would just roll around really crazy?
Because it's not touching anything.
It's not touching anything. Why isn't it touching anything? Because it's being itself, but what qualities does the liquid nitrogen have that would mean it's not actually touching the table if I poured it on the table? How cold is the liquid nitrogen?
You said negative 321 degrees, right?
What do you see right here?
Oh.
What's happening?
Shots.
What's creating that fog?
The coldness. Your breath.
What's happening to it? It's quiet here. So when it evaporates as quickly as it does, and you saw the expansion rate, when it evaporates that quickly, it doesn't even touch the table when I pour it on the table.
Oh no.
Just for fun, what's going to happen inside this room?
It's gonna blow up.
What's going to happen? Do we blow up?
Nothing happened.
No, it's gonna end up inside you.
Another one?
Oh my God, did not fit that in there.
How is she doing that?
Remember, we're in an office building, everybody.
That's dope.
Don't worry.
It's still popping. Pop.
Very good balloons. They expanded and then they contracted. All right, we want to thank you for coming here to Fermilab. I want to remind everybody that basically any type of job that would be at any business, we have here at Fermilab. It's a really cool place. So basically, you know, if this is a place that you might want to work someday, it doesn't matter if you go into physics. I went into graphic design, and we've got other people here, someone in the main control room majored in art. We've got people here that are working in the cafeteria, all the way up through management. So really, we have any jobs available here that you could dream of. Does anybody have any final questions? Yes. Yeah, I am a docent. These ladies are docents. Have you ever been to a museum and taken a tour at a museum? A docent is the person who leads the tour. It basically means teacher, but it's for a different type of thing. We're not teachers at a school. We're teachers here at the lab. Yes, question back here. I'm sorry?
The last one.
A red balloon.
The last one.
No, actually, we've got to get down to the buses.
Oh, wait, it took like 10 seconds.
Alright, so the balloon is a little bit too big, but what's happening to the air inside the balloon? It's shrinking. What? It feels sucked in. Shrinking. Not the air, the balloon is shrinking, isn't it?
That should be a new weapon. I don't see nothing going on it. Oh, no, never mind. Well, I have to put that on somewhere. Question.
Bro, they're good.
The metal, right? Why are you dropping it?
Sounds like popcorn.
Wait, why is it like this shape?
My God. No caben todos. No caben todos. Hey, allá me esperan.
Sean is there.
That's why I don't have back here anymore.
Excuse me. Okay.
Right?
Wait. Okay. You go. Déjame voy con ellos. Okay. Okay.
First?
Yes, the first one.
What?
First? Number one? Number one?
Pensé
que iban a entrar o...
No.
Oh, my head. My head hurts. That's why I don't sit on my
No,
knees.
se siente más feo de subida que de bajada.
10th floor.
This not do that hard. Oh, ladybug. Oh, yeah.
Okay.
Orange. Just already runs. You don't know by you. Oh, grabbing ladybug. If it grabbed in, look. Wait, so Cassie.
Cassandra, ¿sí te dio Natalie el tu ID?
Sí.
Sorry.
You want a high five?
Otra vez.
I heard you that bad? Same. For real? That's our yard, so...
Okay.
You want me to get out? You guys can come in?
No, es el piso.
Squish, squish.
I can come out, you guys can get in.
Sorry, you guys like on a field trip?
Yeah.
We didn't know if you were on a field trip or just getting into riding the elevator.
I don't think that would be fun. At least for me.
Okay,
yeah.
Okay. Let's go. Thank you.
Is it this one?
I'm being nice.
Thank you. We're here. It's time to go home. I can go. Bye. Oh, sorry.
Angel, I swear.
No.
Hey, Jeremiah, get out of my seat. I remember because I was sitting in front of the seat. Come on, let's go.
Can I sit here?
I got my balloon.
Well, that was a good trip, I guess.
Kristen, are you gonna stay with them or here?
I guess this is a good trip.